Hello everyone, I'm Monika. I'm here to present back-to-back stations. Let's see, what is back-to-back? Generally, in electronics and power electronics, if two bipolar components are connected in series with opposite polarity, then this pair is known as back-to-back system. As same as in electrical, rectifiers and inverters are identical and connected in series is known as back-to-back system. From this diagram, here rectifier and the inverter are connected in series via a HVDC link. Hence, it is also a HVDC back-to-back link. A back-to-back HVDC link. The HVDC system which transfers energy between two AC buses at the same location is called as back-to-back system or an HVDC coupling system. In other words, the converters and rectifiers are installed and operates on high voltage DC in the same stations. Hence, there is no DC transmission line. So, it reduces the overall conversion cost and improve the reliability of the DC system. Such type of system is designed for bipolar operation. This picture shows the bipolar link of a back-to-back link. A bipolar link has two conductors, one is positive and the other one is negative. This link has two converter stations at each end. The midpoint of the converter station is connected to the earth through the electrodes. Next, we are going to see about the construction of back-to-back HVDC link. The main components are converter station, converter unit, converter valves, converter transformer, filters, high frequency filter, reactive power source, smoothing reactors, and then system pole. What do you mean by converter valves? There are two types of converter valves. One is the sending end converter and then receiving end converter. The sending end converter acts as a rectifier which converts AC into DC. The receiving end converter acts as an inverter which converts DC into AC. What are converter transformers? These are transformers which are used before the rectification of AC in the HVDC system. Filters. Filters may be AC or DC. What is the use of high frequency filters? These are provided to suppress the high frequency currents. What do you mean by smoothing reactors? Smoothing reactors are those which is used on the DC side to smoothen the DC current as well as the production purposes. This shows the simple block diagram of back-to-back HVDC link. From the system 1, AC current is converted into DC by means of rectifier and the current DC is supplied via DC link and it is converted back again to AC by means of inverter and then distributed to the different grids. It shows the simple block diagram. Working principle of back-to-back link. Two independent neighboring transmission systems which with incompatible electrical parameters such as frequency or voltage level or short circuit power level are connected via a DC link. The basic principal operation of a HVDC linking system is based on the conversion of AC to DC and vice versa by means of converter valves. Power from two or more system is first converted into DC by means of power rectifier system and then summed up. After summing up, the resultant power is again converted into AC with the help of power inverter and then supplied to different grids. The process involved in here is simple only by theoretical, but in practical it is very much complex as it involves high voltages and power semiconductor devices. What are the needs for back-to-back stations? We all know that high voltage AC is used to transmit the electrical power for reducing power transmission losses. In a transmission system, different grids are interconnected, but sometimes it might happen that one or more grids or power systems may not be in synchronization with other grids, or there exists a weak link between different power systems due to various factors. To overcome these problems, HVDC back-to-back system is created. It also can be used when two asynchronous AC systems need to be interconnected for a bulk power transmission and also for the stabilization processes. These are some examples of back-to-back stations. McNeil HVDC back-to-back station, HVDC back-to-back link commissioned between India and Bangladesh, Chandrapur HVDC back-to-back station, Vizag back-to-back station, Vindhyachal back-to-back station. We will see them one by one in the following slides. McNeil HVDC back-to-back station. A back-to-back station is a series of HVDC interconnectors between the unsynchronized eastern and western AC systems of United States and Canada. It connects the power grids of Canadian provinces at Alberta and Saskatchewan. The station was built by Gek Alstom, was commissioned in 1989 with a power capacity about 150 megawatt at a DC voltage of 42 kilovolt. This picture shows the back-to-back station at Alberta. McNeil station was notable for operating with a low short circuit ratio. What do you mean by short circuit ratio? Short circuit ratio is a measure of how strong or weak the connected AC system is. Most of the HVDC schemes uses line commutated converters with SCR about 3. But McNeil scheme was designed to operate with an effective SCR which is even less than 1.0 on the Saskatchewan side. So hence it was the only SCR with the lowest value ever achieved with the line commutated HVDC converter. It is also considered as the first HVDC station to use three-phase four-winding converter transformer. The transformer which are connected at 138 kV at Alberta side and 230 kV on the Saskatchewan side. The number of poles used in this link is about only 1. Next, we are going to see about Indo-Bangladesh link, a HVDC back-to-back link commissioned between India and Bangladesh. This Indo-Bangladesh link was commissioned by Siemens. Here, two back-to-back links are installed. The block 1 is in operation since 2013 with a capacity of 500 megawatts. Siemens recently announced that in June 2020, it fully commissioned the second block of HVDC back-to-back line in Baramara at Bangladesh to connect the electricity supply network to India and Bangladesh with a transmission capacity of 500 megawatts. Hence, a total capacity is up to 1000 megawatt, which is the highest reliable power capacity in Bangladesh. Siemens is a world leader in HVDC technology, which has installed more than 55 projects worldwide with an overall capacity of 94 gigawatts. This picture shows the back-to-back stations at Biramara at Bangladesh. This is the map which shows the back-to-back HVDC link between India and Bangladesh. Here, from Biramara at the west border of Bangladesh, a 230 kilovolt grid of the country will be connected via substation and OH lines to India's 400 kilovolt grid, which is located at Baharampur. Next, we are going to see about Chandrapur back-to-back HVDC station. It is a back-to-back HVDC connection between western and southern regions in India, located close to the city of Chandrapur. Its main purpose is to export power from the Chandrapur Super Thermal Power Station to the southern regions of Indian National Grid. This picture shows the power station at Chandrapur. It was owned by Power Grid Corporation of India and the installer for the substation is Gek Alstom and commissioned in 1997 with a power capacity of 500 megawatts at a DC voltage of 205 kilovolt at each pole. Next, we are going to see about Vizag back-to-back HVDC station. Vizag back-to-back HVDC station is a back-to-back HVDC station connection between the eastern and southern regions in India, located close to the city of Visakhapatnam in the state of Andhra Pradesh. It was owned by Power Grid Corporation of India. It has two substations, namely Vizag 1 and Vizag 2, commissioned in 1999 by Alstom and the later in 2005 by ABB, which has a power capacity of 500 megawatts and a DC voltage of 205 kilovolt 205 kilovolt at Vizag 1 and 176 kilovolt at Vizag 2. It consists of two independent poles. The station is no longer required for its original purpose of linking eastern and southern grids, although it can be still used as an embedded power flow device to help control power flow within the AC system. Next, we can see recent developments. Power Grid Corporation of India has chosen Siemens to upgrade India's oldest HVDC link. Which is the India's oldest HVDC link? Any guess? Vindhyachal back-to-back HVDC link is the India's oldest link. And Siemens has been chosen by Power Grid of India to modernize it. Next, we can see some of the advantages of back-to-back HVDC link. Power can be upgraded to desired frequency. Then, two asynchronous systems can be joined successfully without loss of stability. Stability of the system is increased as well as power flow can be maintained within the limits. More active power can be added where the AC system is already at the limit of short circuit capability. Then it also helps in the stabilization of weak AC signals, weak AC links. Thank you.